So hi everybody, thank you so much for coming. So this is basically, I have like these 2 1-hour presentations that I'm going to try and like cram into 45 minutes. So I'm going to talk kind of fast and I'm just going to kind of get going. So let's get started. So I am here on behalf of Firebase. We are a proud sponsor of 360 iDev, and this is a little bit of a sponsor talk, so let's get this out of the way first. So, oh my God, do you know that Firebase is a set of interconnected products that makes it easier for you to develop more successful apps? We have like a real-time database. You can sort of store and sync your data in the cloud, and Crashlytics and crash reporting, and like a cross-platform notification service, and remote config, and performance monitoring so you can find out where your app is running slow, and a whole lot more. All designed so that you can spend less time on boring infrastructure work and more time on developing the unique parts of your app. You should totally try it. It's awesome. Yay. So, all right, we got our money's worth. We don't actually have operators standing by, but we do have a very nice website. So there's that. Okay. So now let's talk about analytics, which is sort of drawn here at the center of this hodgepodge of icons, because it's at the heart of a lot of what Firebase does. It's sort of a visual metaphor, which is very exciting. So I think most of us understand to some degree why analytics are important, right? They're sort of the best way for you to find out what people are doing within your app. And by finding out what users are doing within your app, you can make it better. So you can find out if there are places where your users are getting stuck, or if there are features they're not using, or if there are parts of your app that are sort of way more interesting or sticky than you had anticipated, and you can go ahead and adjust your app accordingly. And there are lots of tools out there to help developers measure what's going on within their app. One of the earliest was Google Analytics. But it was really targeted more for websites. And you can kind of sometimes see that in the way it's designed and set up. It's got sort of a lot of web pagey terminology and in the reports and the way it processes information. It also limits you to about 10 million hits a month before you need to upgrade to a Google Analytics 360 subscription, which is very nice, but for smaller developers on a limited budget, it's a little bit of an issue. So at around this time last year, we introduced Firebase Analytics, which was sort of built as our mobile-centric solution. It's kind of designed from the ground up to actually reflect the way users interact with native mobile apps. It is free and supports an unlimited volume of hits, no matter how many users your app might have. So sort of from our perspective, this really is the way mobile app developers or native app developers should be measuring what's going on within their app. And so in fact, a few months ago, we renamed the product from Firebase Analytics to Google Analytics for Firebase, sort of as a way to reflect that this is the solution that Google is recommending for all mobile apps moving forward. Also, fun fact, our marketing people get paid by the word, so it's like double the payment there. So while your old Google Analytics mobile library will still work, I think you're going to see all the major changes and improvements in Google Analytics for Firebase. So what better time to learn about it than now? So there are 2 major pieces of information that make up analytics data. There's going to be events and user properties. So nearly everything you want to record within your app, whether it's a user opening it for the first time or making an app purchase or visiting your store, completing a level, is recorded as an event. So let's take a quick look at the anatomy of one of these things. Events are made up of names, followed by up to 25 different key value pairs. And these are parameters that describe what's going on with the event. If you're, actually this might be up to 50 now, I'll have to check. But if your user completed an exercise, maybe you record some information about that workout, like what workout it was, how long it took, and so on. And so in Google Analytics for Firebase, these parameters can be strings, integers, floats, or doubles. Now, some events are recorded automatically for you by the SDK and sort of reported without your having to do anything. Most of these are probably obvious, but I do want to call out a few. In-app purchase, that's something we record automatically to keep track of purchases made within your app, and we use that to sort of report in-app revenue. You'll see user engagement show up an awful lot in your logs. This is basically an event that we record fairly frequently whenever we notice that the user is still using your app in the foreground. And this is kind of how we can measure overall user engagement on the device. We sort of see this appearing regularly. We can say, okay, they're still using your app. If you link your account with AdMob, you can get ad impression and ad click events automatically, and this will let you see sort of how much money you're making off of your ads, which ones your users are clicking on, and so on. And then Screen View will automatically record what view controller your user is on. So you can sort of find out where they're spending your time within their app. Those of you who are making game kit games where you sort of only have one view controller but like multiple scenes, you can also override this and set your own values. This is also useful. This gets reported to Firebase crash reporting. So like if you sort of want to see like where your users were spending their time before a crash happened, we send these events, which is kind of useful. So there are a number of suggested events. And these are events that are basically sort of predefined in the analytics library for you. And they're basically just there for developers that are like, I want to use analytics, but I don't know where to start. And we're like, hey, look, here's some constant that you can try. And so that's basically all they really are, is just sort of, we've defined a few constants for you so that you can kind of get started. Although in a few situations, and you'll see this later, because Google knows a little more about the context of some of these events, we can provide you with some slightly better reporting specific for these events. But the majority of the events that you're going to be creating are custom ones. And you're probably going to create a ton of custom events within your app. You know, I think you can define up to 500 different types. And this is anything that's relevant to your app, like unlocking an achievement in a game, viewing a recipe in a cooking app, showing that, hey, want to review our app dialogue, anything like that. I'm not going to spend a lot of time showing code because for the most part, it's not very interesting. This is the call to login event. In our latest Swift-friendly release, this parameter is a string in any dictionary, but do make sure that the parameter values are, ints, floats, doubles, or strings. Don't try and send another object or something. That'll just confuse us. So the other major feature you're going to be recording are user properties. And so the idea behind user properties is that as a user interacts with your app, you might learn a little more about them, like what their fitness goal is if you have a fitness app, or what their favorite musical genre is, or how they pronounce GIF, which as you can see here is the correct way. And so the idea is that while events define a distinct moment in time where a user has performed something within your app, user properties are more sticky. So they get associated with all events for that user from that point forward. And so the idea then is you can use this information to start to filter your events by these user properties. So maybe you're curious if your yoga enthusiasts are more likely to spend money within your app than your weightlifters. And so you can go ahead and kind of filter that in-app purchase property by the fitness, or the in-app purchase event by the fitness goal user property, and you can kind of see for yourself who's spending more, and then maybe you know where to dedicate your marketing dollars moving forward. Setting a user property is basically this: set user property for name. Here, both values do have to be strings, but that's about it. So let's actually see some of what you get by plugging in this SDK and look at some of the reports. So this is the Firebase dashboard for a game called Bingo Blast. This is an actual game that's out there in the App Store. You can try it. It is kind of fun. And this dashboard shows you sort of a high-level summary of everything that's going on within your app. Almost all this information is being reported by those automatically tracked events that I showed you earlier. So you kind of just get this out of the box. This is, for the most part, reports you've probably seen in other analytics libraries, so I'll kind of walk you very briefly through them. Here we have active users, and this is sort of daily, monthly, weekly active users. Average revenue per user, ARPU, and average revenue per paying user, which is ARPPU, which is my favorite acronym ever. Here we have ad performance. We'll show you for your ad mob ads, basically sort of which ads your users are viewing, which ones they're clicking on. I'll talk a little more about this later because you get some cool reports here. Here we have retention cohorts. So this basically kind of shows you, how users are retaining in your app over time. We sort of break out these users by weekly groups or cohorts, so you can kind of see over time, is my app getting more sticky or less sticky, and what's happening there. First, open attribution. I'll talk a little more about attribution later, but this basically lets you see sort of what marketing campaigns are driving people into your app in the first place. That can be very useful. In-app purchases, you can see what the most common ones are, what people are paying, all of that. User engagement, how long people are spending with your app, how long they typically spend per session. And then below here, we can actually see sort of what screens your users are spending their time on. It looks like, actually, I don't think these folks have gone ahead and customized their events, because this all looks like fairly standard. Hey, you're using GameKit, and this is the root view controller. But in your app, it'll be much more interesting. App version, make sure your users are upgrading their app in time, and see if there's sort of any older versions of your app you need to support. And devices. This will show you sort of the most common devices that people are using your app with, and sort of what operating systems. Kind of interesting to note here, we have actually a fair number of people still on OS 9, presumably because they're playing on older devices. So that's good to know. And then down at the bottom, you'll have some demographic information, like you'll have sort of country, and then some general sort of age and gender, as well as interests kind of information. So these are generally estimates that are provided to you from Google based on its advertising information, but for a large enough sample, these should be generally pretty accurate. So these are sort of the basics of what you get by integrating the SDK. And this is kind of nice to sort of gauge the overall health of your app. but if you want to answer more specific questions, you're probably going to have to look at other things. And so this is the events panel. And so all these events you've been recording, this is sort of where you can see a summary of all these reports. And if you were to click through on any individual event, you could get sort of some detailed reports here. So for instance, this is the round completed event for our bingo game. Up here we have the event count for sort of the last 30 days. This solid line here is basically sort of the most recent 30 days of people who are completing rounds in our bingo game. And then this dotted line is sort of for the previous 30 days. You can start to see maybe trends over time. And this large graph does sort of correspond to the smaller thumbnail that you've got up here. And then in addition to just sort of raw event counts, we can show you users. So we can track the number of unique users over the last 30 days. I should note that for the purpose of our calculation, a user here is really more a unique app instance, meaning that if the same user were to actually use your app on an iPhone and an iPad, we would count that as two separate app instances or two separate users. So just kind of keep that in mind if you look at this value. And then we have the number of times an event occurred for each unique user. And then you get sort of a few additional reports for any event that you record. Again, you get country information. Where are people who are, completing rounds in my bingo game? Where are they coming from? And then we get sort of the demographic information, as well as, I guess, how many times an event occurred in a particular session. So if we were to look at our demographic information, it might look like sort of the majority of my audience who are completing rounds of bingo in my game are older women. But are they as active as my younger players? Like maybe there are more of them, but they play less. How could we find that out? And so here we can filter that by one of our user properties. So like if I were to select this Add Filter button, I now have the option to filter this event by some of these user properties. By the way, these I did not have to explicitly record as a developer. These are ones that I get from Firebase Analytics kind of for free. Things like app version and device model. They're all recorded automatically. So if I had to look at just the data for like my under 25 group, I could see, both the number of users, but more importantly, this count per user number seems to have gone down. If I were to compare this for, what I get for the 65 and over crowd, for example, not only are there more users, but they're also playing more rounds in my game. And so I could start to use this information to, actually figure out where I want to focus my advertising dollars and sort of what users are sort of most interested in my app. And so this is kind of a fairly standard report that you'll get for an event, but I want to take a look at a few other events, starting with a couple of predefined ones. So here's in-app purchases, the same kind of graph as before. One thing you might notice right away is that if we kind of scroll down a little bit, you can see we have some extra reports that go along with it, like what the most popular items were, average purchase price, and so on. And then we get all this demographic information and so on. And just like my round completed event, I can filter this in-app purchase one by all those user properties. So remember how we had a whole bunch of users that were on OS 9.3.5? Well, I can see if these users are still spending money in my game, because that might determine how much time and effort I wanted to spend on supporting older versions of this operating system. And here it looks like I'm still clearly making some amount of money on these users, and so maybe it's worth kind of supporting them moving forward. Similarly, my ad clicks and ad impressions report contains a lot of kind of nice information. Again, because Google Analytics for Firebase understands the context of these events, they can show me some very specific information. So here I can see like ad impressions as well as total ad exposure time and clicks and estimated revenue for all of my ads. And I can break this down by sort of what type of ad, what ad unit, what screen it's being shown on, and so on. In this case, Bingo Blast actually only has one type of ad, which is sort of an interstitial that pops up in between rounds. So this is the only breakdown I get. But if you had multiple ads, this would show you which ads your users are interacting with and which ones they're ignoring, so that maybe you can sort of start to find that nice balance between making money in your app and not turning away your users because you're showing them sort of too many ads. And so I do want to kind of bring up one interesting point here, which is that both this report and my in-app purchase report contained a bunch of other information about the event because sort of Google Analytics understood the context around it a little better. On the other hand, this round completed event, by default, I don't really get anything else, even though I'm passing in a whole bunch of other interesting parameters, things like sort of type of game and bingos claimed and squares daubed and so on. This is stuff that as a game developer, I might be very interested in. What is the average score that our users are getting in this game? And it used to be you actually couldn't get access to any of these custom parameters without first going through BigQuery, which I will talk about shortly. But one recent change we made, and it was probably our biggest feature request by far from developers, is that now you can start to get information about these custom parameters. So we've got this, add event parameters button down here. And you can start to request, hey, these are the custom parameters that I want to see reports on. So you can sort of bring up the parameters, ask Google Analytics for Firebase to track them. You can specify whether it's going to be a text value or a numeric value, and if it's a number, you can specify the unit of measurement. And then you start to get reports that look a little like this. We'll kind of show you, hey, for your text values, which ones are most common, which ones are happening most frequently. So here it looks like we've got a lot more people playing solo games than social games, for instance. For numeric values, we can show you sort of average or sum, depending on kind of what makes sense over time. And so this was definitely sort of a welcome addition. Lots of people were happy we added this. But I will point out you are still limited to a total of 50 custom parameters per app. And if you want to get sort of fancy math reports like standard deviations or quartiles or anything like that, you're a little bit out of luck. But hold on to that thought because I'll get back to it in a second. But I just sort of want to go over a few other sections that you get in Firebase Analytics. Audiences, they're kind of a neat way of sort of creating ad hoc groups of people that have met certain conditions in your app, like triggering an event a certain number of times and or having a certain user property. Two big caveats of audiences, though, is that they are not retroactive. So it's only after you start defining an audience that your users will start to fill up that oh yes, they've met the criteria for this audience. And two, once a user joins an audience, they cannot leave it. So you can't create an audience of like people who have browsed my in-app store but not purchased anything, because once they've made a purchase, they will still be in that audience. So from my experience, the best use for audiences is to identify users that are important to your app, like users who have made in-app purchases or have completed 10 or more levels in your game, anything like that. Because then you can sort of do neat things like target this audience for remarketing campaigns in AdWords, or send them notifications, or that kind of thing. But for ad hoc queries, they're actually not that great. Funnels, they're sort of a nice way of visualizing how frequently users progress from one event to another. One big thing I will point out here is that these are open funnels, meaning that sort of users will be counted in the funnel if they trigger an event at any point. So honestly, it's really less of a funnel and more like a bunch of event counts all displayed side by side. So this tutorial progress funnel, this is actually probably a good use of our funnels because sort of nobody in the game can trigger this tutorial complete event without first triggering the tutorial started one. So I can say, I'm pretty confident that 82.6% of our users have completed the tutorial, or who started the tutorial completed it. On the other hand, maybe this social sign-in flow is misleading. Like let's say we're popping up a, hey, you want to sign in with Facebook kind of dialogue. And we want to see, is this been successful in driving sign-ins? Well, if we were to look at this funnel, the first impression you might get is like, wow, 2/3 of our users who saw this dialogue clicked the yes button, which would be sort of amazing. But it turns out that might not actually be happening. So the deal is anybody who signs in through Facebook through any means, whether it's sort of through like a pop-up dialogue or the main menu or maybe some user settings or however else they could do it in your app, would also get included in this number. So depending on how your app gets users to sign in, this number may very much be inflated. On the other hand, if you want to create a custom Facebook sign-in from this pop-up dialogue event, that would then make this sort of a much more accurate funnel. So that's sort of how you can deal with funnels in the Firebase console. Now, if you want sort of just a more intuitive sense of what's going on with your app overall, I recommend checking out StreamView. Let's see if the video runs. Oh, yes. All right, cool. So this basically gives you a view of what's going on with your app right now. So here I've got StreamView open for an app, and I can basically kind of see a sample of like all my users and what user properties they have and what values they have for those user properties. Well, let's take a look at sort of what common events are happening. And within some of these common events, I can take a look at some of these event parameters and actually see them for our users. So it's important to note that sort of in many cases, you'll be getting a sampling of all the data coming in. But if you want something resembling sort of real-time analytics, and you just sort of want to get an overall sense of, okay, how are people interacting with my app right now? StreamView is actually really cool. You can also view sort of anonymized individual user journeys like this. On the other hand, if you're just interested in making sure you've implemented analytics correctly, you can take a look at debug view. So during development, if you have debug mode turned on for any of your test devices, you can see exactly what events are happening and what bugs you might encounter on that particular device. So this is sort of a nice way of like, my analytics aren't showing up, I wonder why. Turn on debug view, try it with the test device, and hopefully you'll be able to see it. And finally, let me talk briefly about attribution. This is a big thing for like marketing folks and growth hackers and that sort of thing. And so the idea behind attribution is it helps you connect users with the ad campaigns that brought them into your app in the first place. So the idea is like, it's really easy for an ad network to tell you, how many ads it's serving and how many clicks you get, right? But like, are they good clicks? It's like, if we were to take a look at the sample report, I would say, oh wow, it looks like, our free campaign is doing great. Like, look at that click-through rate. It's amazing, right? But if you think about it, these are probably the people who are least likely to make an in-app purchase in our app because, they like free stuff. And so how do we know that these are getting us users that will, that will be valuable to us? And so that's sort of the idea behind attribution. So the idea is basically, if some ad network is running an ad for your app, when your user clicks on that ad, instead of just redirecting your user to like the App Store or the Play Store, well, I guess on iOS, the App Store, the ad network will first tell your analytics provider, in this case Firebase, that the user, as identified by their IDFA, has clicked on this ad. So your analytics provider will make a note of that fact and say, okay, this user, they last clicked on this ad campaign. So later, when a user opens up your app for the first time, Firebase Analytics can notice that this is a first open event, and it will check with its records to see if it's recorded any previous ad clicks from that user. If it has, well, now it can tell you, oh, okay, this particular ad, generated an install because now I know this user has opened up your app after seeing this ad. And that's sort of way more useful information than just like, oh, the user clicked on an ad. And similarly, if like the user were to like share the app with their friends or make an in-app purchase, that's also information that Firebase Analytics can record and sort of, again, attribute to that whatever ad campaign they clicked on. And so you can specify up to 10 events within your app to be conversion events. And these are the ones that are sort of important enough that you want to attribute them to an ad campaign. Like first open and in-app purchase are there by default. Those are pretty good ones. Other good candidates might be sort of, completing 10 exercises in your workout app, something that indicates they really gave your app a good try, or clicking the, why yes, I'd love to review your game on the App Store kind of button, something like that. So here's an example of one report we've got. It's tracking first opens. But if we look at sort of some of the other information we get, we also get like total revenue and average lifetime value that this app is getting through each of my various ad campaigns. And within these reports, you could also break this down by like ad network or specific campaign within that ad network. And then you can start to see which ad networks are performing well and which ones are giving you sort of users that are actually more willing to spend money in your app and what their lifetime value is. And you get to a point where your user acquisition costs are less than your lifetime value, you're on your way to a profitable business, which is nice. So this is a lot of stuff that we give you, and basically for free, which I think is pretty darn good, maybe to a point where you're wondering what the catch is. So let's go back and think about some of these limitations that we had. And some of them might seem a little weird, right? Like, why would we only limit you to 50 custom parameters? Or why can't you filter on more than one user property at once? And I think the key to understanding why we have these limitations is understanding how analytics processes its data. So the way Firebase Analytics works, Google Analytics or Firebase, sorry, is that every day the service gets millions upon millions of events for all your apps. And every few hours they process all this raw data into these generated reports that we've been showing you. And while these reports are kept around for you to view at your leisure, this raw data is not. Which means that if you want to run like complex ad hoc queries on historical data or export your data to use with other analytics packages, or simply kind of run specific reports that we could not think to generate ahead of time, you're going to need access to that raw data. And so that's where BigQuery comes in. BigQuery is basically sort of a data analytics warehouse in the cloud, which means it's a service designed to run very fast queries over very large amounts of data, usually using SQL. Like, for instance, all that analytics data that your app has been generating. And so the idea is when you link your Firebase account to BigQuery, which you do through this handy little panel in the Firebase console, it's hidden in settings, but you'll find it eventually. Then when all this data gets sent to Google Analytics, a copy of it is also sent to BigQuery. And BigQuery stores this data as soon as it receives it in like this temporary table that you can query for essentially real-time analytics, the intraday tables. And then at the end of the day, it converts this to sort of a more permanent table that you can keep around for as long as you want. And so I'm going to kind of show you a demo of what it looks like querying this data. But before I do, I want to explain what the analytics data looks like in BigQuery. Because if any of you have done any kind of playing around with BigQuery and maybe some of like the sample data that we have for you to try, it kind of looks like this, sort of like some very nice tables that you might see in a MySQL database. But it turns out BigQuery is much more sophisticated or complicated than that. So the rows that you get in BigQuery don't necessarily have to be single rows that consist of sort of one line of column-like data. They're more like individual JSON trees, each of which can contain like key value pairs or arrays or objects or arrays of objects. And that's sort of important to understand when you're looking at analytics events in BigQuery, because the first thing you're going to assume, the first thing I assumed anyway, was that every row in BigQuery corresponds to a single analytics event, and that's not always the case. More often, a row in BigQuery will consist of like a bunch of user information and then usually like 2 or 3 events all sort of bundled together in the same row. So let me show you what our actual data schema looks like here. So this is a row of analytics data in BigQuery. See, simple. Though I know it seems a little intimidating at first, but let's get to know it a little better because it's actually not too bad once you break it down. So the user info section contains a few straightforward key value pairs, like first open time or an optional user ID parameter. But then they also contain a number of nested objects that sort of have their own set of data. Things like sort of the device that the user is interacting with. There we go. Their geographic location, their traffic source information, which is essentially that attribution information I was talking about, and so on. And then we also store user properties that we've associated with this user in Firebase Analytics. Google Analytics for Firebase. I still like the old name. And these properties are basically stored as an array of objects, because you can have up to like 25 of them per user. And so these objects will contain the name of the key and then the value, which itself is its own little object that has a few fields that I almost never use, and then its own other sub-object called value. I don't know why they called it that. I think that's a little confusing. But anyway, this value object then has 4 other fields called int value, float value, double value, and so on. And you'll find that in practice, most of these are null, except for the property that contains the actual value that you want to record. And the idea here is this basically allows you to store any number of user properties in any format, and they're kept inside your BigQuery table in a consistent manner. And so the nice thing about keeping user properties in a big array like this is that basically there's sort of one less join I need to worry about later when I'm building up my queries, and you'll see that in the demo in a little bit. So then in addition to all this user information, there's some event information. As I mentioned earlier, BigQuery sort of stores these Firebase Analytics events as an array of like 3 or 4 event objects, all bundled together in the same row. And these contain a few straightforward key value pairs, like the name of the event and the time that it occurred. But then they also contain an event of these event parameters, because you can have up to either 25 or 50 of them. And similar to user properties, these are objects that contain the name of the parameter and the value itself, which is its own little object that has string value, int value, and so on. And this holds true for every event parameter in the array, and that holds true for every event within this event array. And so that's our entire data structure. So yeah, it's a lot of stuff, but it's not quite so bad once you get to know it. So I'm going to jump into BigQuery so we can actually answer a few questions that we weren't necessarily able to answer alone from the Firebase console. What is sort of the average and the standard deviation of our score in a bingo round? Let's say I haven't, set up my custom event report for score, or I want some more mathy information about it. How does score correlate with player XP? That's something we've been recording as a user property. How can I get that correlation? And this is kind of an interesting one. What's causing our users to spend money? So with that, I'm actually going to jump into, I'm going to turn off mirroring here, or I guess turn it on, and jump into BigQuery. All right, hopefully you all can see that. I can't get it too much bigger. So when you first sort of open up BigQuery, what you get is you'll sort of see the schema here, and this essentially mirrors that giant tree that I was showing you earlier. And so I'm going to start by querying this table. Oops, I'm going to use standard SQL instead of legacy SQL. And let's start by looking at our event dim. So this was basically our array of events. And so this is basically running on Bingo Blast data, or a slightly sanitized version of Bingo Blast data. And I might have to shrink it just a little bit to show you the results, and then we'll go back. But basically, as you can see here, okay, it's showing me my event array. And it looks like in here I've got, an entry called round completed, and actually I think probably this one also looks like a round completed event. And you can see within this event, I've got my, parameters array, and it's recording things like type of game, bingos claimed, score, and over here the score int value is the score I'm going to be interested in. So I think we can kind of start querying this. So I'm going to select this, And because I want to focus on the round completed events, I'm going to say where event.dim name equals round completed. And so I'll run this, and I get this kind of strange error. Cannot access field name on a value with type array struct name string params array. And you're like, well, what's that all about? So let's go back to the slides very quickly and I'll explain. Oh no, there we go, sorry. And so the deal is that event.dim is actually an array, right? It's an array of these little event objects that do have a name field. But you know, the array itself doesn't, right? It's an array, essentially, or I guess a repeated record as it's called in BigQuery. And so how do we actually get at these little sub-objects? Well, for that we use a function called unnest. So let's imagine I've got, you know, my table of starships, right? And in there I've got my crew and my ship name and my wingspan and some other stuff. And I would say, hey, you know what? Show me all, you know, spaceships that have a crew member named Zoe. Well, right now I can't do that. I can't say crew.name equals Zoe or anything like that because, you know, just like with my event.dim, crew is an array. But what I can do is I can say select from starships, cross-join unnest crew as crew member. And what that magical incantation does is it says, hey, you know this crew array, I want you to expand that out into a new field called crew member, where basically you're going to take every individual member of that crew array and make it its own value in crew member. And so sort of everything kind of gets copied over. The original row gets multiplied as many times as you need to sort of get at that crew member. And then usually just because we like slightly simpler syntax, that cross-join unnest ends up getting replaced by a comma. But now what I can do is now I can actually query that individual crew member column if I want. So I can say, all right, now let's find those starships where the crew member equals Zoe. And I can get just that. And note, by the way, if you want, you can sort of get that original array as well as the individual crew member field. And so with that in mind, I'm actually going to go back to my BigQuery. And hopefully you can all see this still. And so what I can do is I'm going to say, all right, well, instead of looking at my event.dim, I'm going to unnest event.dim as event. And then I can say, well, now I can actually look for where my event.name is round completed, and I'll select my event.dim. And so I'll run that. And now I'm looking at just the events that are called round completed. And so now actually getting at that score parameter is kind of similar. Like it's also in an array. So I'm going to say, all right, well, I'm not only going to unnest my event.dims, but let's unnest my event params as parameter. And I'm going to look at also not just where my event name is round completed, but my param.key equals score. And instead of looking at the entire event, let's look at our param.value.int value as score. So I'm going to run this. And now you can see down here, I'm getting all of just my score values from all these round completed events, right? And so I'm able to sort of extract that from all of my various event parameters. And so now I'm actually pretty close to like being able to do some math stuff on it. So I can select my average. I get my average score like that. And I can also get my standard deviation. Let's just copy and paste this. Run that query. And I get that as well. And yes, it is mathematically possible to have a standard deviation that's larger than your average. It just happens when you sort of have like these kind of crazy wide values that often happens in a bingo game. Well, let me bring up my cheat sheet here and make sure I'm doing everything right. And so actually now we're getting pretty close to being able to answer our second question, which is what's the correlation between our average score and like the player XP? So I'm going to bring that up as well. Let me kill this average here, and let me kill our standard deviation. And so player XP is also a user property, so I'm going to unnest that. So let's unnest our userdim.userProperties as userprop. And then I can look at not just where my event parameters are equal to score, but I'm going to say our userprop.key equals XP. What's that?
Oh,
Oh, there we go. Thank you. Yeah, I don't think I've ever been successfully able to pull off this presentation without adding a bunch of typos. And then let's actually show you our user prop .value, .string value as our XP, just to kind of, so you can kind of see what this looks like. And I forgot a comma here. All right, now it's happy. This little check mark here will let you know whether your query is valid or not. That's how I knew. So now it looks like I have my score alongside my XP. One thing you might recall from the API is that user property does have to be recorded as a string value. So if I actually want to get correlation, I have to cast this as an int 64, which is kind of annoying. And now what I can do is I'm going to call core, which gets me the correlation on these two values. And I'll run this. And I get, 0.17, a slight positive correlation, which is kind of what you might expect from a bingo game, right? Because there's a little bit of skill there in being able to get better at like figuring out sort of, which balls match to which squares, but it's also still mostly luck. And so that's what we're showing here. So I think I do have time to show you that last query. And honestly, it is my favorite one. So let's see if I can bring that up. Let me just call out my saved queries here. And let's start by showing you this. So what I'm doing is I want to actually look at now, let's look at our events where the name is spend virtual currency. This is where our players have decided that they do actually want to spend at least virtual money in our game. This is very important to me as a game developer. This is where I might potentially be making money. And so maybe I want to find out sort of what's leading up to this. What is sort of causing my users to spend money? And so let me show you a few things here. So I'm going to select our event name. And I'm going to select our user dim app info, app instance ID as app instance. And what app instance ID is this is essentially a unique value assigned to that instance of the app running on that device. And this sort of lets you keep track of events that are happening with the same user. It's still anonymous. You can't really, associate this with an actual user, but it lets you see, what events are happening sort of in the same app. Not necessarily in the same session, possibly across different sessions as well. And then I'll also look at our timestamp micros as event timestamp. And let's order this by app instance and event timestamp. And so what this is going to do is this is going to basically show me, here we go, so you can maybe see it a little better. Oh, and you know what? I'm going to get rid of this. I want to see all events. And so basically, this kind of gives me essentially a journey of what events are happening for every user as they're playing their app. So basically, I can kind of see this user started by initializing some API and then logging in, then spinning some slots and spending virtual currency and so on. And this kind of keeps going until we get to the next app instance, which is sort of a new user. And I can follow their events as well. I suppose by sort of scrolling through all of these, I could kind of get a sense of sort of our individual user journeys. And this is kind of a neat start, but I think there's sort of more we can do here with statistics or something. And so this is another crazy function that I've never heard of before. Have you ever heard of the lead function? All right, what this does is it basically says, hey, let's peek ahead into a future row in the database and grab that value and put it here. So I'm going to say, let's look at our event name, sort of one row ahead. And I sort of have to say, well, how's that being ordered by? So I'm going to say order by this app instance ID. Whoops, put that down here. And our event timestamp. There we go. And we'll run that. And now you can kind of see this, this column here is showing me, hey, here's the name of the event that happened in the next row. So user logged in, slot spun, spend virtual currency, and so on. This looks pretty good until I get to this point where it's telling me, hey, the next thing that happened is first open. And you're like, well, how can that be? what it's actually doing is it's looking at sort of the next app instance and reporting that, and that's not actually what we want. So I can fix this by, instead of saying order by, I'm going to say, you know what, let's partition by, which sort of breaks this out into little mini tables, and then I'll order by our event timestamp micros. And so I should get essentially the same values as before, except that here it's saying, oh, the next event that happened after your user engagement was null because we sort of moved on to a different app instance. And so now I can kind of do something cool. Let's bring event name down. And we'll call this like step 1 or step 0. We're engineers, right? We start with 0 as step 1. And let's do this whole thing again as step 2. And why are you complaining? Let's see what error I get. Trailing comma. Oh, why don't you allow trailing commas? SQL. It also bothers me that you have to use single equal signs for conditional equals. But now we have triplets, right? We have triplets of events that are happening within our app. So it looks like, you know, spend virtual currency, select content, spend virtual currency. These are sort of all things that are now happening, like little event triplets. And then what I can do is sort of from this results table, I can actually sort of query from it. So let me make sure, yeah, that's it. So I can now, this is also something I've never done before in SQL, and maybe all of you have, but like when you sort of have this results table, you can then perform another select on it. So I'm going to say, you know what, let's select step 0, step 1, and step 2. And while we're at it, let's do count as count from this query. And I'll do that where step 2 equals spend virtual currency. Actually, you know what, here, I'll remove the count for the moment. Because I spelled virtual wrong. And now it's showing me just the triplet of events that have ended with spend virtual currency. So now, let me bring back that count, and I'm going to group this by step 0, step 1, and step 2. And while we're at it, let's order by count descending. I run this last query, and this is basically going to show me all the triplets of events in the sort of most common order that they happen of things that are causing my users to spend money. And so that's kind of cool. I can then maybe start to get a better sense of like what's happening right before my users decide to spend virtual currency in my app. And I could probably start to drill into this a little more. If the round completed won versus round completed lost, and what types of items they're buying after each one. But this is really neat. It kind of gets you to just sort of see a lot more of what you can do with BigQuery. So there is a lot more you can do with BigQuery, most of which I don't really know because I'm still kind of figuring it out myself. But if you do have questions about this or about Firebase Analytics, Google Analytics for Firebase, or anything else, I'm going to be hanging out by the Firebase table for the rest of the day today, and I should be here for most of the day tomorrow. So come by and chat. And with that, I'm going to say thank you very much for attending. Yeah, we don't have time for questions because then you got a couple minutes. All right, I have 2 minutes if you want to ask questions now. Otherwise, find me at the table outside. I'll say, find me at the table.